Hi guys, hope everyone is doing well and stayed safe. So I welcome to all our seventh session of the webinar series. Actually, this is our last session of this series. So thank you for joining with us actually until last session. So in the previous session, we went through the Azure DevOps and if you miss something, if you miss session, you can always go to our playlist on YouTube and check it out with our social media. So if you have any question today, you can drop in the chat, and end of the session, we will be having a Q&A session. So you can ask from your question there. So about today's speaker is Kamal Ratnayak. He is our technical lead at 9TrainX with over 6 years of experience in industry as a full stack developer and developer. So yeah, I will invite Kamal. Kamal, over to you.
Yeah, thank you, Rashan. Thank you for the introduction. Good afternoon, everyone. Let me share my screen first. Okay. Yeah. As Rashan said, this is the last session of Azure of the series, and in this session, we are going to learn about Azure Container Apps. And to give you a little brief introduction to who I am, I'm Kamal Ratnayak. I'm currently working as a technical lead at 9TrainX. And the one thing that you should know about me is that I love Microsoft Azure. So today's session. So basically, in this session, we are going to learn about Azure Container Apps. And Container Apps is a new feature on Azure. It's a relatively new feature on Azure. It went its general availability like 2 months ago at Microsoft Build this year. And in today's session, I'm first going to cover the history of microservices. I mean, Container Apps can be used for deploying microservices. I'm going to start the session with the brief history of microservices, containers, and container orchestrators, and these types of services. And after that, I'm going to introduce you to Azure Container Apps. And I'm giving you the history of container apps, history of microservices, because with that you'll be able to understand where container apps fits in the whole spectrum of these services that can run container-based workloads. And then I'm going to go through the common users and features of container apps, and then the structure of container apps. I mean, how it's structured, what are the environments, and what container apps are. And even though container apps is a relatively new feature, it has a lot of new service. It has a lot of interesting features already. But in this session, I'm just going to cover the basics like ingresses and revisions, the basics of it. In addition to this, there are many other features that are already available in container apps. And after that, I'm going to end the session with a few quick demos showing you how to deploy your first application with Azure Container Apps. So let us look at let's look at the history of microservices. Now, if you think back to like 20 years ago, right, like 2005, 2003, we didn't have these things called microservices. All we had was big monoliths. And the term microservices, micro web services, was introduced by Peter Rogers at 2005. And back then, really, we didn't have microservices. But in around 2011, microservices, people started to use microservices. Engineers built applications, and companies started to build microservice-based applications around 2011. And also, if you look at the period of 2012 to 2015, that I would say as the golden era of microservices and these modern applications, a lot of things happened in that period, 2012 to 2015. We had the initial release of Kubernetes, and we have the initial release of Azure Service Fabric that also runs this. It's basically a basically service orchestration system by Microsoft. With that, you can also run microservice-based applications. Now, if you think about Kubernetes, now when you hear the term containers or container orchestrators or microservices, the first thing that comes to mind is, first orchestrator that comes to mind is Kubernetes. Kubernetes was actually used by Google internally, and it was initially called Borg Actually, it was 2003 they initiated the project, and it was initially called Bog, and that is the system that they used for running their services. And then it was called Omega on 2013, but it was still an internal version of it. And then it was and then they released the public version of Kubernetes, and that's where we started calling it Kubernetes. Now, basically, this is the best kind of system for running microservices. Basically, it has a lot of power, and basically Google runs Google runs Google on Kubernetes, and because that has that level of data center scale power to run these types of highly scalable applications. And at the same era, a lot of companies like Netflix, they adopted these microservice patterns, and they succeeded in the industry when it comes to scalability and delivering these modern applications, and a lot of packaging mechanisms around containers evolved. And around 2018, cloud service providers like Azure and Amazon, they rolled out their managed versions of these Kubernetes, like Azure AKS and Amazon EKS. And in addition to that, Azure, they had other services that runs these container-based workloads, like container instances. So basically, if you really think about it, these microservices, containers, and container orchestrators, these are now mature, and we have established set of patterns and established set of tools already to run microservice-based applications. But Azure releases these container apps, a new feature, new service on 2022. Now, what problem does this solve? Now, that's what I want to address now. Container apps is it's built for running microservices using as a serverless platform, as a serverless way. Right? I'm going to go into the features that it has, why it's different from other services now. Now, if you think about it, is it just another container orchestrator like Service Fabric or Kubernetes? Is it just another container orchestrator? If you really compare that to Kubernetes, it is not just another container orchestrator, because if you really think about Kubernetes, as I said, Kubernetes has a lot of power. You can build amazing, highly complex applications, highly complex microservice-based applications on Kubernetes. You can run tens of hundreds of microservices in them, and you can manage the scale. And basically, you can create clusters, computer clusters. With this power, Kubernetes introduces a lot of complexities as well. For most of the applications, for the 90% of applications that we develop every day, we don't need to deal with this kind of complexity. And that is where container apps comes in, because they have it's a managed service. It hides all the unnecessary complex things, and it gives you the exact tools for building microservice-based applications. The first point is deploy containerized apps without managing this complex infrastructure. Basically, you don't manage clusters. Like when you work with Kubernetes, you manage clusters, but here we don't manage clusters, because just like if you worked with Azure App Services, it is that easy for deploying container-based microservice applications with container apps. Now, these container apps, they support wide variety of application types. You name it, you can run that workload on container apps. Basically, you can run HTTP APIs, microservices, event processing applications, like listening to the service bus queues and things like that. You can run those kind of workloads. And also, in addition to that, you can run background tasks as well. And, and this has a robust auto-scaling capabilities as well. Like based on HTTP traffic, you can scale out. Based on event triggers, you can scale out. Those are the scaling capabilities that Container Apps has. And one other interesting thing about this Azure Container Apps is that it is actually built on top of Kubernetes, but you don't have the control to manage. You don't have the control over the Kubernetes cluster, actually, because that's managed by Microsoft. It is built on Kubernetes. It has all the power to run microservices, and it can run Kubernetes style apps easily without kind of worrying about the infrastructure, all these advanced configurations. And it supports service discovery and traffic splitting and all these features. And as I said, it does not support direct access. It does not give the direct access to Kubernetes APIs, because actually you don't need that level of access. And with these restrictions, container apps can enforce best practices for building applications, and that is a good thing. And the best thing actually about this service is that it is fully serverless, right? And that is the key point that I want to highlight here. It is fully serverless. It's just like if you worked with function apps, right? You're only paying for what you actually use, right? And just like that, container apps, they're fully serverless, and you're only paying for the actual running time of the container. Basically, when a container app receives a request, it scales up from 0 to 1 instances, and you only have to pay for that one instance only. But if you compare that to, for example, Azure Kubernetes, the cluster is running always, and you have to pay for it, even though you're not using it. That's the key idea here. And now let's try to understand and compare other services that can run microservices, the containers on Azure. Now, if you think about these services, app services, they can run containers, and container instances can run containers, and obviously Azure AKS, they can run containers. Now, if you really think about it, app services is a platform as a service, but you have to pay for the whole month if you're using it. It's not developed for running container-based systems. You can run just one container or maybe a Docker Compose file, but it is not a full platform for building microservices. Now, if you think about container instances, it is also a serverless service for building container applications, but it is not for building complex microservices applications. Now, if you think about Azure AKS, it has a lot of power, but it is too complex for building 90% of the applications that we develop every day. And now this is where container apps comes in. If your application is a service, if your application is a microservice-based application, and if you don't need to deal with the complexities of Azure Container Apps, Azure Kubernetes, you can go with Azure Container Apps. And this is where Azure Container Apps fits in with all the other services that we have on Azure. Now, if you look at the the features of Azure Container Apps, if you already work with Kubernetes, this supports Kubernetes event-driven auto-scaling and things like that, basically to auto-scale these containers, these container apps. This supports Dapper framework. This has a tight integration with Dapper framework. If you worked with that, it's a framework developed by Microsoft for developing microservice-based applications. This has a tight integration because Dapper has this sidecar pattern that are heavily used, and Kubernetes kind of container apps fits into that model really well. So you can run Dapper-based microservices, and just like in Kubernetes and other container orchestrators, we have HTTP ingressors, simple HTTP ingressors. And in addition to that, we have the public and private container registry supports and secrets. And one of the interesting features that container revisions, basically you can do very easy blue-green deployments with container apps, and I'm going to go into in depth into these container revisions later. And you can do traffic splits. So basically with revisions and traffic splitting, you can easily achieve blue-green deployments. You can test out new features and new versions of your applications very easily. And when you deploy these microservice applications, the microservices, they need to talk to each other. And because of this, you need service discovery. Azure Container Apps has those kind of things. And in addition to that, we have VNet integration as well. Let's say if you want to deploy your container app in a private environment without hosting it in a public manner so that you can access it through a VPN, you can very easily integrate your container app with a virtual network as well, and you have a very tight integration with log analytics as well to view the telemetry. What is going on inside these containers or get all the logs into a log analytics workspace. Is a really easy thing to do as well. Now, if you look at the kind of apps that we can build with container apps, basically, as I said earlier, you can build any types of application you want. You can build public HTTP endpoints, and here in the below the screen, we have the auto scale criteria for that type of an application. If you're building public endpoints, you can scale the service based on the number of concurrent HTTP requests. And if you're running a background service, you can scale out the service based on the CPU and memory load of the service. And if you're building event-driven processing services, You can use the number of messages in the queue based on that type of a scale rule. You can configure these scale rules. You can use that kind of a configuration to scale out. And if you're building microservices, you can easily use SCADA and Dapper to to scale out your application. Now let's understand how this is organized, right? So if you think about app services, I think most of us, if you have worked with Azure, you worked with Azure App Services. Now, App Service has this concept of an app service plan, right? You create the app service plan initially when you create the app service, and that contains all the other app services, right? That's basically the structure that contains other app services. That is the app service plan. Kind of similar to app service plan, we have environments in container apps. So basically, before you're creating an container app, you have to create an environment, and that environment contains all of your container apps. So basically, the container app could be a microservice. The environment is the big application that hosts all those microservices. As I said, this is the highest level of organizational structure of the highest level of organizational structure we have, and an environment can contain multiple container apps, and you can have many containers running inside of it. There can be revisions as well. As you can see in the screen, there can be I'm going to go into this later, deeper in a deeper way later, but we can have multiple revisions of your app as well. To kind of the version 1 and version 2 can be active at the same time. So that's what a revision is. And as I said, the environment acts as a secure boundary around your application. So basically, all the container apps that are within an environment is deployed in one virtual network. So the idea here is that the traffic between these container apps will not go over the internet, will travel through the virtual network, and that is the idea here. And this is directly from Microsoft documentation, like the reasons to deploy a container app in the same environments and not to deploy a container app in the same environments. Basically, if you have kind of related services that talk to each other, you can go with you can deploy the container app in the same environment. But if they don't talk to each other, if they don't share, if they shouldn't share the common compute and common communication systems, you should not go with the same environment for multiple container apps. Now, if you look at the containers that we can run in this service, this supports any Linux-based service. As of now, it doesn't support Windows-based containers, and the containers can come from any public or private registry. So basically, there's no required base container image or anything like that. You can run any image here. And basically, if you're familiar with ARM templates and those types of things, there's a section in that ARM template, basically the infrastructure as code template of this container app. There's a section called revision scope. If you make a change to that revision scope, there'll be a new revision, the new version of the application automatically getting deployed. And if the container crashes, it automatically restarts. And now let's understand the idea of revisions, right? Azure Container Apps, they implement versioning by creating revisions. So basically, these revisions, it is a immutable snapshot of a version, right? I'm going to do a demo as well with this, so don't worry if you're not understanding this well now. So basically, the first revision is created when you first deploy the application, and after that, you can make changes to the revision scope. So basically, the container revision scope contains the environment variables and the tags of the container and a few other scaling rules. And these are the things that this revision scope contains. If you make a change to that, there'll be new revision getting deployed. And you can retain up to 100 revisions basically in one container app, and to giving you a historical record of your container app updates. And you can run multiple revisions concurrently to achieve these blue-green types of deployment scenarios. For example, let's say you deploy the version 1 of your application, and you deploy the version 2 with new features, and you want 20% of your users accessing the new version 80% of your users accessing the old version, you can do this very easily with container apps. And when it comes to these revisions, as I said, there can be single active revision or multiple active revision. As I said, to achieve these types of blue-green deployment scenarios, you should go with multiple active revisions. If you just want to deploy new versions and keep a historical record of all old versions, you can go with single revision mode. So there's a mode that you can select from the Azure portal. And now if we talk about the ingresses, if you work with Kubernetes, Kubernetes also has this idea of ingresses. So basically how traffic comes into the service. Azure Container Apps has everything managed for you. Basically, if you want to expose traffic, if you want to expose your service to outside world, you can enable an ingress. And so basically, you don't have to create any load balancers or anything like that. It is basically managed for you. And if you look at the URL structure of Azure Container Apps, this is the URL structure of it. If you have worked with app services, you have Azure websites.net. Just like that, we have Azure Container Apps.io, and we have the region of the deployment, and we have the unique ID of the container app environment, and we have the name of the container app. So this is how it's organized. And these ingresses, they support all the basic requirements of an ingress, all the for running TLS, it supports basically this SSL termination. So basically, we have the ingress receiving SSL traffic, but it does not send that SSL traffic. It does terminate that in the middle. And it supports WebSocket or gRPC types of connections as well, in addition to HTTP traffic. And we have HTTPS. And so basically the port 80 and port 443, and these are the only ports that you can expose. And, that is enough for hosting HTTP-based workloads, and the request timeout is 240 seconds in these ingresses. Yeah, and so basically, you can, when you create these ingresses, you can assign the target port as well. And to access these service, you can have external ingresses and internal ingresses as well. For example, if you want microservice A talking to microservice B, you can go with these internal ingresses. And now if you think about the pricing, as I said, this is a fully serverless service. So basically this is built per second resource allocation. And this has a free tier. I mean, it's basically free for the first 180K vCPU seconds and 360K GIB seconds, and 2 million requests each month are free, just like in Azure Function Apps. Basically, this is a fully serverless service. All right, now you have an understanding of what the service is, kind of the basics of it. Let me show you a few demos on how you can deploy your first container app. Now let me go into Azure portal, and here I have created this resource group already. Now let me create a first container app. So I'm going to click create here to create a new resource, and then I'm going to search for container app. Now we have the service here. Let me click create. And we can select the resource group to deploy this the container app. And as you can see here, we can name this application, and this is not a globally unique name, right? For example, you can add the first app or something like that. That's very weird. Usually it's not a globally unique name. Let me add quick start. Okay. All right, now we have to specify the region here. Let me go with the North East. And now, as you can see, we have to select the environment. This is the container that contains the container. This kind of the high-level structure that contains these container apps. Now, let me create the container app environment. Now here, as you can see, we can name the environment as well. Let me call it quick start. env. All right. All right, now if we go into monitoring tab, when you create a container app environment, you have to specify a log analytics workspace as well. Just like I said earlier, it has a tight integration with log analytics workspaces. And now if I go into networking, we can integrate this container app environment with a virtual network. So here we can select the virtual network if you already have one. So the thing that you should keep in mind is that when you enable this, when you enable this, what happens is that there's a new resource group. In addition to the resource group that we have already, there's a new resource group that is getting deployed with the prefix MC underscore. And in that resource group, there will be all the load balancers and the Kubernetes cluster related information that you can access. If you do this, and you have to pay extra if you're going with this feature because you have the control to all these load balances and things like that. For this demo, I'm going to go with no virtual network integration. Okay, I have specified the information required for deploying the environment. Now let me go next. And here we have to specify the image information that we're deploying here for this container app. We can go with this quick start image, kind of the simple hello world container that the kind of the default thing, or we can give our own container for this. Let me call it quick start app. And as you can see, the image source, it could be an Azure Container Registry, or it could be a public or any other Docker registry. So I'm gonna pull this image, a sample application that I have created for this. And as I said, it's basically a public, it's in public Docker Hub, and the image type is a public thing. And this is the login server. And I'm just going to add the image, and I'm going to add a tag as well to specify to get the v1 of this image. And I don't have any command overrides or anything like that. And here we have to specify the CPU and memory. As you can see, it's kind of a weird way of specifying it, like 0.25 CPU cores and 0.5 GI of memory. And that's the way that we specify resource allocation for these container apps. The idea is that we are running microservices, right? I mean, they can be small and we don't need a lot of resources to run them. So yeah, so we have configured the image and the resource allocation and all that. Now let me enable the HTTP ingress because we want to access this from our browser. So as you can see, when I enable this HTTP ingress, we can select these. We have three options here. We can go with limited to the container apps environment, or we have this grayed out option, limited to the VNet, and accepting traffic from anywhere. We have the third option. So basically, if you enable this option, the container app will not receive traffic from the outside world, but it's still the other containers in the environment can access this application as an internal service. This option is grayed out because we have not done any VNet related configurations for this environment, and because of that, this is grayed out. As you can see, we are going with this option, accepting traffic from anywhere. Yeah, we are going with that option, and we have the target port, and this is the port that the container that you specify is listening on. You have to specify the target port here. This application, this image is listening on port 80. And now that is complete. I'm not going to specify any tags here. I'm just going to create this container app. This usually takes like a minute to create, and until this gets created, let me show you another. Let me show you, give you an idea of what I'm going to do. What I'm going to show you in my next demo. As basically, it is a simple application. Let me show you the application as well. It's basically a simple ASP.NET application that I'm going to deploy into container apps. Basically, it has this, let me show you the architecture of it. It's basically a simple container app that interacts with an Azure SQL database. Now, this is the application, and I have deployed into Docker Hub. And if I go into this file here, this is the script that I'm going to use to deploy this application into Container Apps. Now let me go back into Azure portal and check whether our deployment is complete or not. It's not still complete. Let me go back and let's discuss about this second demo until that is completed. As you can see, what I'm doing here is that with this CLI script, I'm specifying these variables here, and I'm creating this resource group. Basically, this is the resource group that I'm creating, and then I'm creating this SQL server and a database inside of it, and then I'm creating the environment. As you can see, we can use Azure CLI to create container apps environment, or we can use ARM templates to deploy them as well. So if you look here, we are first creating the environment. I mean, even though we have done it in one step here, we have to create step by step. When we interact with this CLI, we are first creating the container app environment. We are passing in the name of the environment and the resource group and the location that we are deploying this in. And then we are creating the actual container app. If you have multiple container apps, you can just add, things like, multiple invocations like this to create these applications. And as you can see in that, we are specifying the image and the target port and ingresses and the replicas and all that in the CLI file, CLI script. And in addition to that, we can pass in things like environment variables and things like that as well. Yeah, okay. Now I'm going back to the first demo. Here we have the application deployed into Azure. As you can see, it's a quick start image. And if you're familiar with Azure, if you worked with Azure, I think this should be very familiar to you. As you can see, we have all the basic information. And here we have all the specific information for these container apps. So we have the application URL, and we have the container apps environment and log analytics workspace. If I click on this link here, as you can see, it basically works. It's a basic application, a basic ASP.NET application. Now let me show you one other thing. If I go into the resource group that we have deployed application in, as you can see, this is the resource group that we have that we used for this. We have 3 resources, right? We have, as you can see, we have the container apps and container app, and we have the container app managed environment. Basically, this is the environment that I told you about. Just like app service plan, we have the container apps environment, and we have a log analytics workspace connected to this container apps environment. Now, if I go into this environment resource, as you can see, it has this IP address and all the other basic information. And if I go into apps, we can add multiple apps inside of this environment, right? And if I now go into the actual app, it shows the environment as well there. And if I kind of scroll through this tab and the features that it already has, as you can see, we can enable authentication. We have this easy auth functionality. If you worked with app services also has this easy auth functionality. Let me go into this link. So basically, with this easy auth thing, you can just enable authentication for your container apps without making any code changes. So basically, what is happening is that this is your application. When you enable this easy auth feature, there's a middleware container as deployed as a sidecar that acts as a proxy to all the requests that your application receives, and the request does not contain the authorization cookie. It does not allow the traffic to go into the actual container. And basically, with this, you can add there's a lot of providers that you can add very easily. Within a minute, you can add like Microsoft logins or Facebook logins. Within a minute, I guarantee you can add these types of authentication features to container apps. And this supports this feature already has in web apps as well. It works in a similar way. And as you can see, we can store secrets, your credentials, your connection strings, and API keys and things like that here as well. And we can do the ingress configuration that I've told you earlier, that I've shown you earlier. We have the same settings here. You can do the changes, and obviously we can do continuous deployments to this. You can assign custom domains. As I said, if your application has Dapper, Container Apps plays. I mean, if you built your application with Dapper, you can very easily work with this thing here. And you can have, all these default things are here. All these managed identities and these things are here. If you want to talk to other services, I think the time is running out. I also have another demo as well. Let me go into revision management quickly. So basically, as you can see, we have deployed this tab, we have deployed this app, and we have one revision automatically created here. And we have an option here to enable, or basically we have this option here to kind of switch between these single or multiple revisions. As I said earlier in my slides, if you want to enable kind of blue-green types of scenarios, you should go with this multiple active revisions mode. Okay, I'm enabling that. And so basically, after enabling that, you can add multiple active revisions at the same time. And so basically, after enabling multiple revisions, we have this option here to show inactive revisions as well. Now let me create one other revision to show you one quick demo. So basically, the second revision that you're creating, basically the new version of your container app, it has all the basic features of the first version. As you can see, that it has the image, and if I go into the image, it has all the default settings. I'm going to change from V1 to V2. So consider this the next version of my application. Let me save this, right? And basically, you can add a naming suffix to this new revision, and also you can change the scaling rules of this new revision as well. For example, V1 could have auto scaling and V2 does not have auto scaling and something like that. You can do all that kind of stuff here. Now let me create this new revision. All right, as you can see, I have deployed a new revision. So basically, this is the V1 and this is V2, as you can see. And the provisioning status is it's under provisioning. Let me try to refresh it. Okay, as you can see, both of these revisions are provisioned now, and we have these multiple active revisions. Basically, these two applications are running at the same time. Now, let's say if you want to make this blue-green type of a scenario now, what you can do is you can just add easily the kind of this kind of traffic splitting kind of percentages here. Basically, 50% of traffic goes into this revision and 50% of traffic goes into the first revision. You can do that kind of a setting here, and then you can save it. So basically, with this feature, you can very easily do these kind of blue-green types of stuff. Now, until this gets saved, let me go into the container section. As you can see, we have two revisions, and if you click on it, we have that revision can contain multiple containers, right? And if you go here, you can configure environment variables, and also we have health probes as well. Just like in Kubernetes, we have these three types of health probes: liveness, readiness, and startup probes. We have these types of health probes here as well. And in addition to that, we can add scale rules. So basically, when you make this kind of a change, there's a new revision gets deployed. Now, seems like we have updated correctly all our revisions. Now let's try to refresh this application again. Hopefully, see here. Okay, usually, yeah, as you can see, now I try to refresh it a few times. As you can see, now I'm getting responses from V2. So basically, this is the idea: 50% of traffic coming from V1 and 50% of traffic are coming from V2, and that is the idea. That's what we have configured here. Now, if I go into the second thing that I wanted to show you is that I wanted to show you this deployment here. And deploying this takes like a few minutes actually, and it's a good thing that I have already done the deployment since we are kind of running out of time as well. Now, if I go into my resource groups again, and in this resource group, I have already deployed this application. By the way, if you want this script, you can get it. I think this will be uploaded to YouTube as well. I'll make sure that this repo is there in the link. So if I go into that resource group, and that resource group contains, as you can see, the SQL Server database and the and all that. And if I go into the actual container app, it's basically the container apps is loading now. It's basically an application deployed in container app that interacts with SQL Server. It's a basic application, as you can see. We have a list of users, and you can add new users. Say something like this. Yeah, it's basically kind of fully functional, kind of a CRUD application deployed in container apps. And if I can take like 1 minute, let me show you one other quick demo. I wanted to show you how to enable authentication for this application. Now, if I click on, if I go into this authentication section and add this identity provider. So this is the cool thing about this thing. You don't have to make any code changes or anything. You just go into this identity provider thing. We just select the identity provider. Let's say it's Microsoft. And since it is Microsoft, we have to create an application in AD. So this application will automatically get created for you. If you don't want a new application, you can pick an existing application as well. So basically, we can select the supported account types. You can go with single tenant or multi-tenant Azure AD scenarios, or we can go with any Azure AD and Microsoft personal accounts as well. I'm going to go with that option. And here, as you can see, and I have already mentioned the architecture of this as well. So basically, when you enable this feature, there's this new sidecar container getting deployed in front of your application, and that kind of monitors all the traffic. And if the request is not authenticated, it directs the user to the actual the ID provider. Could be Google, Microsoft, or Facebook, or anything. It will do the redirection. And basically, I'm going to restrict access here, as you can see. And if an unauthenticated request comes in, do the redirection. That's what I'm specifying here. And this will redirect to Microsoft. And I'm going to go with, I don't need any specific permissions here, and I'm going to go with this default setting. And let me add the identity provider now. All right, so this can probably take, okay, yeah, it's done. As you can see, we have this identity provider added, and you can add multiple identity providers as well. You can add Microsoft, Google, and multiple identity providers into a single app without making any code changes. Now let me go back into the application and let's try to refresh it and see what happens. As you can see, I'm getting directed into Microsoft login page. And since I have already logged in, it does the this SSO thing, and yeah, now I'm presented with this auth kind of consent thing. I can I'm gonna go ahead and say yes. And yeah, as you can see, I'm logged in as the user. So basically, when you do this kind of login, there's this interesting thing happens. So basically, this sidecar container, it does all the magic here, and it does set the these auth cookies and all that. Now, if I go into network tab, let me try to refresh it. And if I go into any of these the requests, oh no, it's not network tab, it's actually the application tab. If I go into this local storage or session storage, I think hope it is just so basically I just wanted to show you that there's this cookie attached to this application session storage. Here it is. Yeah, Here, as you can see, this it's basically this ASP.NET cookie-based authentication automatically set up for you. As you can see, it does contain the cookie here. So this container does all the magic here. And it is a really interesting use of sidecar pattern as well. Yeah, so this is what I wanted to cover in this session, everyone. I just wanted to show you, wanted to give you an introduction to Azure Container Apps, and basically I wanted to give you an introduction, and then I wanted to show you what's possible with Container Apps. And yeah, thank you so much.
All right. Yeah. I would like to thank Kamal to accept our invitation and taking a bit of time for us, so in a valuable time. So thank you, Kamal. So yeah, guys, as I said, today is our last session actually in this series. So thank you so much for everyone for joining with us until last session. So we meet again another session series. Until then, goodbye.